This is Abin Elowitz for Physics 2211 for Lab 1, object moving at a constant velocity. So the purpose of this lab is to analyze the horizontal motion of an object at a constant velocity, in this case a baseball, and determine how its position will change over a certain time period. In this lab, we will create a computational model of this motion via glow script, as well as compare the theoretical data with our experimental. So the results from our object's motion versus our glow script model, and we will draw a conclusion, which in this case was both the glow script and experimental, which is from tracker graphs that had a similar slope that didn't change, showing how there was no acceleration and constant velocity. Key physics concepts here are velocity, which is the speed of an object with a direction, Newton's first law, which states an object in motion will stay in motion, and an object at rest will stay at rest unless acted upon by an external force, and Newton's second law, which is force equals mass times acceleration, both of which are observed here because of how, with Newton's first law, the baseball is remaining at rest until acted upon by the force me pushing it, and continues in motion with a constant speed and direction as no unbalanced force is acting upon it. The assumptions of data here are that the ball is rolling with zero friction and is assumed that the surface is flat and the ball moves in the path with no changes. The mass of the ball is 0.141 kilograms, the starting position is 0.000 meters, and the initial velocity and final velocity are both 1.14 meters per second in the x direction. So here is attached as our tracker data and observations. As you can see, the ball is rolling in a straight line with the data points going up the slope of distance over time. And as you can see, the slope appears to be pretty much a constant line with no interruptions or breaks trending upwards. This shows how the slope, since the slope is constant, the velocity of the ball is not changing as it moves. And as you can see, here's a close-up of the graph here. You can see how that slope is relatively constantly increasing at a consistent rate. Next, to prove this further is my glow script code. What this code does is simulate the model of an object at the constant velocity by creating a loop that updates the object's position at a constant rate on a fixed interval. And it shows the expected motion of the ball versus the actual. So right here, you can see the modeling. I'll play this demonstration for it to showcase again the model of the object in motion with no acceleration. As you can see, the white orb is following the same path as my baseball, and the theoretical graph of position versus time is the same as it was slope-wise and trend-wise as the one for my tracker data. And the secondary graph next to it showcases again how the velocity is at the same rate over a period of time. Here are the two graphs side by side. You can see position over time and position over time. Both have a constantly increasing slope that remains the same throughout, showcasing constant velocity. Some possible errors here could have been mismeasurements when setting up my tracker data and my tracker point of reference, as well as since I was manually entering the tracker point at the center of mass, those could also be slightly off. The conclusion here is we can see how both Newton's first and second laws are applied to an object in motion with no external force because of how, since the ball's acceleration is zero, that proves there is no force acting upon it, as force is equal to mass times acceleration. Acceleration is zero, making the force zero. And the first law applies in how the object is remaining in motion at a constant speed as seen through the tracker scripts. This interaction is modeled through glow script, and when compared with the experimental results, we can see how the trend lines are the same and the velocity is constant with no acceleration. If we change the axis and directions of motion, what that would impact is, well, no acceleration would occur if we turn the axis in the tracker, for example, so it appears the ball is moving diagonally. We have to account for both the x and y components of velocity to prove there are no acceleration. And if we did apply a force onto the object, if it was going in the direction of the ball's motion, the ball would accelerate. If it was going against the ball's motion, the ball would decelerate. And theoretically, if it was pushed down upon the ball while in motion, the movement would not change as it would not impact the x component. That's all. Thank you.
You're smart.